then
I feel like everything he's explaining is like we are clubbing baby seals with the shield that is in my hand in order to generate enough power to fire up the engines in the server room to do the AI training necessary to upscale the performance of a shittier chip that will give you 4090 equivalent performance through the AI training. The amount of baby seals I am clubbing is unimaginable.
Look at that. Disco lights in here.
I have lit the rainforests on fire. Do not go there.
If we had to build this
they are
as
done.
one chip,
They're
obviously
dead.
this would be the size of the wafer, but this doesn't include the impact of yield. It would have to be probably 3 or 4 times this size. But what we
Why would I watch another streamer with 81 viewers reacting to the NVIDIA keynote instead of just straight up sending me the NVIDIA keynote? No CDG for me.
Hi, Emma. We're going to take a sample today, okay?
What is this,
Don't
the NVIDIA
worry,
keynote?
I'm gonna be here the whole time.
They bring meaning to numbers to help us better understand the world around us. Predict the dangers that surround us. And find cures.
What is
for the
going
threats
on?
within
Why
us.
are they doing are they doing AI hype? What is this? Is just AI slop? God, I hate everyone. AI is gonna solve the world's problems.
And restore what we've lost.
Zachary, I got my voice back, buddy.
They help us move forward. One small step at a time. And one giant leap. Together.
NVIDIA's an AI company now. I'm just waiting for the bubble to burst. It doesn't matter. NVIDIA is an everything company. When will you not? When will you understand? NVIDIA is an everything company. They literally say whatever the new trend is because that's what the market responds positively to. They were also a blockchain company. They were also a cryptocurrency blockchain company when that was what was popping. Are they still a blockchain company? No, I don't think so, but it doesn't matter. They said it at the time.
Founder and CEO Jensen Huang.
Just put the 5090 in the bag, little bro. I don't care about any of this other stuff. This is all for the birds, okay? All of the AI and the blockchain and whatever, the everything app, whatever they're saying is just for institutional investors to go, oh, Pog, they said the right words.
From Gary Shapiro. I'm in Las Vegas after all. If this doesn't work out, if all of you object, well, just get used to it. I really think you have to let this sink in. In another hour or so, you're going to feel good about it. Well, welcome to NVIDIA. In fact, you're inside NVIDIA's digital twin. And we're going to take you to NVIDIA. Ladies and gentlemen, welcome to NVIDIA. You're inside our digital twin. Everything here is generated by AI. It has been an extraordinary journey, extraordinary year, and it started in 1993.
Ready, go!
With NV1, we wanted to build computers that can do things that normal computers couldn't. And NV1 made it possible to have a game console.
Toss on the
in your
jacket
PC.
is ass.
Our programming architecture was called UDA, missing the letter C until a little while later, but UDA, Unified Device Architecture. And the first developer for UDA and the first application that ever worked on UDA was Sega's Virtual Fighter.
Someone said it might be
6
Philip
years
Line.
later.
Oh my God, is he an international motherfucker.
1999, programmable GPU.
Or maybe he's a cryptocurrency bro. I guess that's why.
20
Bitcoin
years,
mining.
20 plus years of incredible advance in this incredible processor called the GPU. It made modern computer graphics possible. And now, 30 years later, Sega's Virtual Fighter is completely cinematic. This is the new Virtual Fighter project that's coming. I just can't wait.
Bro made it seem like this is what it would look like in 1999. Come on,
After
dog.
that, 6 years after 1999, we invented CUDA so that we could explain or express the programmability of our GPUs to a rich set of algorithms that could benefit from it. CUDA initially was difficult to explain, and it took years, in fact. It took approximately 6 years. Somehow, 6 years later or so, 2012.
Bro, the 4090 is
Alex
so
Krzyzewski's
big, it just
Julius
ruins,
Susscover
like,
and
there's
Jeff
no,
Hinton
it eliminates
discovered
half the
CUDA,
slots in my motherboard.
to process AlexNet and the rest of
By
it
that
is
standard, the 5090 is just
AI
going to
has
need
been
an entirely
advancing
new
at an
one.
incredible pace since. Started with
5090 is
perception AI,
bigger?
now
Stop!
can understand images and words and sounds. To generative AI, we can generate images and text.
It's going to be like
sounds.
this big. It's going to be
And now,
going to need its
agentic
own
AI.
power supply.
AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI, 2012. Now, magically, 2018, something happened that was pretty incredible. Google's Transformer was released as BERT, and the world of AI really took off. Transformers, as you know, completely changed the landscape for artificial intelligence. In fact, it completely changed the landscape for computing altogether. We recognized properly that AI was not just a new application with a new business opportunity, but
Yeah, right.
AI, more importantly, machine learning,
Yeah,
enabled
right.
by transformers, was going to fundamentally change how computing works. And today, computing is revolutionized in every single layer, from hand coding, instructions that run on CPUs to create software tools that humans use. We now have machine learning that creates and optimizes neural networks that processes on GPUs and creates artificial intelligence. Every single layer of the technology stack has been completely changed. An incredible transformation.
You're being a hater,
just
contrarian
12
of the Reddit kind. I hate AI so much. I
We
hate
can
it.
now
I hate it. I hate it.
understand
I hate it. I
information
hate
of
it.
Just about any modality. Surely you've seen text and images and sounds and things like that. But not only can we understand those, we can understand amino acids. We can understand physics. We understand them, we can translate them, and generate them. The applications are just completely endless. In fact, almost any AI application that you see out there, what modality is the input that it learned from? What modality of information did it translate to? And what modality of information is it generating? If you ask these three fundamental questions, just about every single application could be inferred. And so when you see application after applications that are AI-driven, AI-native, at the core of it, this fundamental concept is there. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. Well, GPUs, GeForce, in a lot of ways, all of this with AI is the house that GeForce built. GeForce enabled AI to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. Let me show you some of it now.
What is this? Personally, I read a bunch of classics in high register in college. I guess it was fun. Recently, I ChatGPT Aristotle into readable English. Finished it around 5x as fast as the translation. I felt I got the main gist of things. I don't know. Does it actually teach much? What? Okay, this looks awesome. Okay, I'm backing on the AI train. That guy sucks. Who the Aristotle ChatGPT nonsense, but this is sick. So AI makes it less costly on the computer? Is that what it is? Like, I'm too stupid to understand, chat. Some of you nerds need to explain this to me. I guess DLS, I mean, DLS is cool.
Was real-time computer graphics. No computer graphics researcher, no computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. There are two fundamental things that we did. We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the colors should be, it has been trained on a supercomputer back in NVIDIA, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS.
I banned him already for a day.
The latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate. What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3, if I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2. It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other.
I saw the leak video having gay sex with Drake. Oh no, it's
result,
out, dude. That's crazy.
We're able to render at incredibly high
What is wrong
performance
with these chatters, bro?
because AI does a lot less computation. It takes, of course, an enormous amount of training to produce that, but once you train it, the generation is extremely efficient. So this is one of the incredible capabilities of artificial intelligence, and that's why there's so many amazing things that are happening. We used GeForce to enable artificial intelligence, and now artificial intelligence is revolutionizing GeForce. Everyone, today we're announcing our next generation, the RTX Blackwell family. Let's take a look.
Isn't the AI predictor still like off though? Like how can it be 100% accurate if it's like filling the gaps? Chatters are also complaining that it's going to make games less optimized because a lot of big developers will pay programmers less, hoping that NVIDIA picks up the slack with its AI.
Here it is. Our brand new GeForce
Wait, how
RTX
that looks
50 series.
that looks smaller than the
Blackwell
4090. What the
architecture.
hell?
The GPU is just a beast. 92 billion transistors, 4,000 tops, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can.
92 billion
and
magoos.
of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is for floating point, one is for integer. G7 memory from Micron, 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation
it's
is
a Founders
programmable
Edition.
Shader
You have a third-party
also
4080
able
with an extra fan. I
to
thought I
now
had a
process neural
4090.
networks. So the shader is able to carry these neural networks.
I have a 4080.
And as a result, we invented neural texture compression and neural material
Oh, I have
shading.
a 4090.
As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Okay, so this is the brand new RTX Blackwell 5090. Now, even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. You know, so the question is, where's the graphics card? It's literally this big. The voltage regulator design
That's
is state-of-the-art.
insane.
Incredible design. The engineering team did a great job. So here it is. Thank you. Okay, so those are the speeds and feeds, so how does it compare? Well, this is RTX 4090. I know many of you have one. I know it. Look, it's $1,599.
Uh-oh.
It is one of the best investments you could possibly make. You, for
$3K.
$1,599, you bring it home
3
to your
racks.
$10,000
3 racks. 3 racks. 3 racks.
PC entertainment command center. Isn't that right? Don't tell me that's not true. Don't be ashamed. It's liquid cooled. Fancy lights all over it. You lock it when you leave. It's the modern home theater. It makes perfect sense. And now for $1,500 and $1,599, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070, 4090 performance at $549.
Wait, what? Wait, what?
Impossible without artificial intelligence. Impossible without the 4 teraops of AI tensor cores. Impossible without the G7 memories. Okay, so
wait, what?
5070, 4090 performance, $549, and here's the whole family. Starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090. Starting, of course, we're producing at very large scale, availability starting January. Well, it is incredible,
what?
But we managed to put these
Are they saying because of AI they can make it for much cheaper? Like, I'm confused.
Into a laptop. This is a 5070 laptop. For $1,299, this 5070 laptop has a 4090 performance. I think there's, let me show you
Scam
this.
4090L. I mean, I don't really care.
This is a, look at this thing. Here. There's only so many pockets. Ladies and gentlemen, Janine Paul. So can you imagine? You get this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense? Well,
They're
you
saying
can't
with
do
frame
that
gen and
without
bullshit is
artificial
comparable to a
intelligence. And the reason
4090.
for that is because we're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate using artificial intelligence all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. And what's really amazing is, oh, here we go. Thank you. This is a surprisingly kinetic keynote. And
4090
really
worth $500 now?
GPUs
Yo, calm down, chatters.
And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti.
Wait till the reviews come out and they actually test the performance of these cards, okay? And match it up against the real power of a 4090. They said a 4090 equivalent, okay? Something about this smells a bit fishy to me, but I am also a Luddite, so I don't know.
Well, GeForce brought AI to the world, democratized AI. Now AI has come back and revolutionized GeForce. Let's talk about artificial intelligence. Let's go to somewhere else at NVIDIA.
Yeah, they democratized it.
This is literally our office. This is literally NVIDIA's headquarters. Okay, so let's talk about AI. The industry is chasing and racing to scale artificial intelligence. And the scaling law is a powerful model. It's an empirical law that has
Is
been
what they're
observed
doing even AI, or is he just simply slapping on the sticker of AI to make it more appeasing to
says that
investors?
The more data you have, the training data that
Like
you have,
as far
the
as like
larger
frame
model that you have,
generation.
and the more compute that you apply to it, therefore, the more effective or the more capable your model will become. And so the scaling law continues. What's really amazing is that now we're moving towards, of course, and the internet is producing about twice the amount of data every single year as it did last year. I think in the next couple of years, humanity will produce more data than all of humanity has ever produced since the beginning. And so we're still producing a gigantic amount of data, and it's becoming multimodal. Video and images and sound, all of that data could be used to train the fundamental knowledge, the foundational knowledge of an AI. But there are, in fact, two other scaling laws that has now emerged. And it's somewhat intuitive. The second scaling law is post-training scaling law. Post-training scaling law uses techniques like reinforcement learning, human feedback. Basically, the AI produces and generates answers based on a human query. The human then, of course, gives a feedback. It's much more complicated than that, but that reinforcement learning system with a fair number of very high-quality prompts causes the AI to refine its skills. It could fine-tune its skills for particular domains. It could be better at solving math problems, better at reasoning, so on and so forth. And so it's essentially like having a mentor or having a coach give you feedback after you're done going to school. And so you get tests, you get feedback, you improve yourself. We also have reinforcement learning AI feedback, and we have synthetic data generation. These techniques are rather akin to, if you will, self-practice. You know the answer to a particular problem, and you continue to try it until you get it right. And so an AI could be presented with a very complicated and a difficult problem that is verifiable functionally, and it has an answer that we understand, maybe proving a theorem, maybe solving a geometry problem. And so these problems would cause the AI to produce answers, and using reinforcement learning, it would learn how to improve itself. That's called post-training. Post-training requires an enormous amount of computation, but the end result produces incredible models. We now have a third scaling law, and this third scaling law has to do with what's called test time scaling. Test time scaling is basically when you're being used. When you're using the AI has the ability to now apply a different resource allocation. Instead of improving its parameters, now it's focused on deciding how much computation
Bro,
to
I ain't got
use
no idea what the
to
hell
produce
he's
the
talking
answers,
about.
It wants to produce. Reasoning is a way of thinking about this.
This is some crazy
long
nerd
thinking is a way
shit,
to
man.
think
Is
about
the
this. Instead of
are the
direct
Marvel
inference on
Rivals
one-
cinematics gonna look sexy or not? Okay, explain to me that, Mr. Crocodile Jacket Man.
your AI system would evaluate which one of the ideas that you generated was the best one. Maybe it solves the problem step by step, so on and so forth. And so now test time scaling has proven to be incredibly effective. You're watching this sequence of technology and all of these scaling laws emerge as we see incredible achievements from ChatGPT to O1 to O3, and now Gemini Pro.
Put the 5090 in the bag, bro.
Are going through this journey step by step by step of pre-training to post-training to test time scaling. Well, the amount of computation that we need, of course, is incredible.
Yeah, I need to know what level of computation is needed to upscale, okay, the new Fantastic Four ladies' bosom. That's what I need my artificial intelligence.
It's the most valuable
for.
asset that we have, and it can be applied to solve a lot of very challenging problems.
That is the most significant computational problem. I need to know what Psylocke looks like.
Media computing is driving an enormous demand for this incredible chip we call Blackwell. Let's take a look at Blackwell. Well, Blackwell is in full production. It is incredible what it looks like. So
What
first
the
of all,
hell?
there's some, every single cloud service
The hell am I
provider now
looking
has
at?
systems up and running. We have systems here from about 15 computer makers. It's being made about 200 different SKUs, 200 different configurations. There are Liquid 86, NVIDIA Grace CPU versions, NVLink 36 by 2, NVLink 72 by 1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world. Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Well, the reason why we're driving it so hard is because we need a lot more computation. And it's very clear that Janine? It's hard to tell. You don't ever want to reach your hands into a dark place. Hang on a second. Is this a good idea? All right.
Why are they clapping? Dude, nerds are so funny. What is happening?
Wait for it. Wait for it.
He's explaining the process of AI training and how to get better performance out of your AI through training and how to do all the training. There are orders of magnitudes of more GPUs needed to do all the pre and post training.
Didn't think I was worthy.
So you need to buy NVIDIA stock.
This is my show and tell. This is a show and tell. So this NVLink system, this right here, this NVLink system, this is GB200 NVLink 72.
Bro, not gonna lie, we need to bully nerds more, I think.
600,000 parts.
It's gotten out of control. I'm on the opposite of the Vivek train, where I think like we need a society that venerates the jocks and bullies the nerds more.
Kilowatts. It has a spine behind it that connects all of these GPU together. 2 miles of copper cable. 5,000 cables. This is being manufactured in 45 factories around the world. We build them, we liquid cool them.
You'd be bullied? Who's going to bully me? Thor Bjornsson?
To the data centers because it's
I love when chatters are like, you'd be bullied too. Bitch, I'm 6'4", 230.
The manufacturing is insane. But the goal of all of this is because the scaling laws are
there's a limited number of people on the planet that can do that to
Blackwell
me.
over our last generation improves the performance per watt by a factor of 4.
Okay, I don't know what you're talking about. If you don't like it and don't understand it, why watch it? Shut up.
Performance per dollar
I'm enjoying
by
it.
a factor of 3. That basically says that in one generation, we reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost. But the important thing is this. These are generating tokens that are being used by all of us when we use ChatGPT or when we use Gemini, use our phones in the future. Just about all of these applications are going to be consuming these AI tokens. And these AI tokens are being generated by these systems. And every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, then
I feel like everything he's explaining is like we are clubbing baby seals with the shield that is in my hand in order to generate enough power to fire up the engines in the server room to do the AI training necessary to upscale the performance of a shittier chip that will give you 4090 equivalent performance through the AI training. The amount of baby seals I am clubbing is unimaginable.
Look at that, disco lights in here.
I have lit the rainforest on fire. Do not go there.
If we had to build this
they are
as
done.
one chip,
They're
obviously
dead.
this would be the size of the wafer. But this doesn't include the impact of yield. It would have to be probably 3 or 4 times this size. But what we basically have here is 72 Blackwell
The shield
GPUs,
erased 4 Pacific Islands. The coral reefs are no more. I have used this shield to eradicate them.
The world's largest supercomputer, fastest supercomputer, only recently, this entire room's supercomputer only recently achieved.
And to be fair, it's worth it. If I could see bouncier titties in my video games, like low key, no matter how hard Naughty Dog tries to make them unfappable, I will fap to them.
Bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips, okay? And we have 130 trillion transistors in total, 2,592 CPU cores, whole bunch of networking. And so these, I wish I could do
petabytes
this.
is for Dr. Disrespect.
Blackwells. These are our ConnectX networking chips. These are the NVLink, and we're trying to pretend about the NVLink spine, but that's not possible, okay? And these are all of the HBM memories, 14 terabytes of HBM memory. This is what we're trying to do, and this is the miracle of the Blackwell system. The Blackwell dies right here.
You should learn how to code. Okay, dude. Just put the DoorDash in the bag, okay?
In addition to that,
learn the code. They told you to learn the code. Now everyone who learned the code is DoorDashing. This literally eviscerated the industry. Things like this.
Is there a chair I could sit down for a second?
It's messed up. Just put the chips in the bag, buddy. I thought he said there's no coders. Yeah, the AI.
Can I have a Michelob Ultra?
AI sounds gonna take over, little bro. Great. What? A Michelob Ultra?
How is it possible that we're in the Michelob Ultra Stadium? It's like coming to NVIDIA and we don't have a GPU for you. So we need an enormous amount of computation because we want to train larger and larger models. And these inferences used to be one inference, but in the future, the AI is going to be talking to itself. It's going to be thinking. It's going to be internally reflecting, processing. So today,
the person giving him the water is a former coder who now has to work at the Michelob Ultra Stadium, fetching his water because the AI displaced their job.
GPT-01. You know, with the new Gemini Pro and the new the 01, 03 models, They're talking to themselves, reflecting, they're thinking. And so, as you can imagine, the rate at which the tokens could be ingested is incredibly high. And so we need the token rates, the token generation rates, to go way up. And we also have to drive the cost way down simultaneously so that the quality of service can be extraordinary, the cost to customers can continue to be low, and AI will continue to scale. And so that's the fundamental purpose, the reason why we created NVLink. Well, one of the most important things that's happening in the world of enterprise is agentic AI. Agentic AI basically is a perfect example of test time scaling. AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it's maybe retrieving information from storage, a semantic AI system like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file. And so it might be using tools. It might be using a calculator.
Studying Dr.
And it might be using a generative AI to generate charts and such. And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all these different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out. In the future, you ask a question, a whole bunch of models are going to be working in the background.
Pause to check, I've melted.
Time scaling, the amount of computation used